All right, today all we're going to do is a little review for our quiz on Friday, which if you're watching this now is today. And this quiz or this review is on arc length, reference angles, and exact values of trig ratios. So let's start with arc length. And you will be given a circle or some dimensions of the circle. So suppose we had this right here, and this was 140 degrees, and the radius is 2 meters, and I wanted to know the arc length. Well, you need to know this formula, S equals R theta, where R is the radius, and theta is always in radians. Well, you can see this one's not in radians, so we need to be able to convert from degrees to radians. And all you have to do is multiply by pi over 180, and if the directions say round to 2 places, then you should not have pi in your answer. So I use my calculator, and all I do is I type this in. 2 times 140 times pi divided by 180. Now, if pi is in your answer like that, and you push this button on this calculator, it'll change it to a decimal, 4.89. And always use your units, 4.89 meters. Okay, so that is arc length. The next type is to find the reference angle. So if you have 3 pi over 5, let's go through a couple things that you need to know how to do. Number one, you might need to know where that is. What quadrant is that in? So I draw the circle, the unit circle. The unit circle has a radius of 1. That's not that important. I take the bottom number, and basically I put that in every single multiple of 90. So put that there on the bottom. Now this one on the right would be 0 pi over 5. The one on the left, just put the bottom number also on the top because 5 over 5 is 1, so that's 1 pi. Up here would be between 0 and 5, which would be 2.5. I know that's enough to answer this one, but I'm going to keep going. And notice I'm just adding 2.5, so this would be 7.5. And if I kept going, because sometimes I might need more, this would be 10 pi over 5. Well, just to check, this one should always be an even pi, 0 pi, 2 pi. This one should always be odd, 1 pi, 5, or 1 pi, 3 pi, 5 pi. So this angle, which is in quadrant 2, is going to be closer to the 2.5. Now, if you have to draw these angles, you must start at the positive x-axis, and if it is positive, we're going counterclockwise, negative, we go clockwise, and you must show that arrow to show the direction of the angle. Okay, so this is in quadrant 2. All right, quadrant 2. And I'm asking for a reference angle, and from a previous lesson we learned that a reference angle is just the distance to the x-axis. So this reference angle would just be how far apart these two are, so you just subtract them. And I know this is a lot of work and I'm really tired. I'll power through. All right, so my reference angle is 2 pi over 5. That's my reference angle. Okay, so arc length, reference angles, now exact trig values. You have to know how to find a reference angle to answer that. But before we do that, let's do something that's super important on this little table. It's probably the most important table in all of trig. It's the most useful one. All right, and this will help me find exact values of my special right triangles, 30, 60, 90, and 45, 45, 90. Other ones we'd have to use a calculator. All right, so you have 0 or 0 degrees, 0 radians or 0 degrees, pi over 6 or 30 degrees, pi over 4, or 45 degrees, pi over 6, or pi over 3, sorry, or 60 degrees, and then pi over 2, or 90 degrees. They're the same. All right, so if you remember when I first showed you this, it's just square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. And then the cosine is just the reverse order of that. So I just write those down because I'm going to need these. And then the tangent is sine divided by cosine. Very, very, very important. Sine divided by cosine. But knowing that, all I have to do is take this 0, divide by 1, which is 0. This 1/2 divided by that, just flip that over and multiply. If you did that correctly, you should get the square root of 3 over 3. Any number divided by itself is 1. Take this second one, flip it over, and multiply. The 2's are going to cross out. You get the square root of 3, and you can never divide by 0, so that's undefined. So let's take a look at an example. Let's say the sine of 4 pi over 3. So number one, I need to know where that is. So I'm going to draw it using that exact same thing I used here. I'm going to take the denominator, which is 3, and I'm going to put it here. I'm going to put it every multiple of 90. And the first one is going to be 0. This one over here, just put that same number on the top. And then between 0 and 3 is 1.5. And so if you just see that, you're just adding 1.5 every time. So this would be 4.5. And if I did one more, this would be 6 pi over 3. Like we said, these are even pi's, and it is. So 4 pi over 3 is over here. So to draw it correctly, you always start your initial side at the positive x. And because it's positive, we go in the counterclockwise direction. So here's 4 pi over 3. So this is in quadrant 3. What does that tell me? Quadrant 3 tells me that the sine is negative. So is the cosine. The only thing that's positive here is tangent. And my reference angle, again, the distance to the x-axis, how far apart are those? Just subtract them and you get pi over 3. So if you look now at your chart, I know my answer is negative. I look over here, sine pi over 3, which is 60 degrees, square root 3 over 2, but it is negative. All right, let's try another one of those examples. Let's do cosine of 315. I'll do it up here. Number 4. Cosine of 315 degrees. So the first thing I'm going to do is draw it just to get an idea where this is. Now we're dealing with degrees. This is 0 degrees or 360 degrees. All the other ones are multiples of 90, so that's 90, that's 180. Down here at the bottom is 270. So you can see that 315 degrees is over here. So if I drew the angle, I would have to do that, show the direction. I know this is 315, so this is in quadrant 4. And I know quadrant 4, my x value, cosine is your x, sine is your y, my x value in 4 is positive. The distance to the x-axis from 315 to 360, if you subtracted those, you'd get 45 degrees. And from my chart, okay, there's positive value, and I'm looking at just the cosine of 45. If you look at cosine 45, it's square root 2 over 2. That's an exact value, right? An exact value. One more. Good practice. Tangent, negative 7 pi over 6. Now if again you have a little trouble with radians, you can always convert to degrees if you're really good at degrees. but I'm not going to do that here. 6 on the bottom, 6 on the bottom, 6 on the bottom, 6 on the bottom, 0 on the top here, but these are negative, so this would be negative 6 pi. Doubled would be negative 12 pi. I don't know how many I need. Between 0, we're going in this direction, and negative 6 is negative 3. Notice 3, 3, this should be negative 9 pi. 3 more, yes, that's right. So where is negative 7 pi over 6? It's between negative 6 pi and negative 9 pi over 6. So again, because it's negative, it's in this direction. This is quadrant 2. I know in quadrant 2, as all seniors turn crazy, only the sine is positive in 2, so the tangent is negative. Number 3, my reference angle, how far apart are these? Well, take away the negatives because it's just absolute value. And those are just pi over 6 apart. If I do my chart correctly, all I got to do is take that sine, come down to my chart and find tangent of pi over 6. So negative square root 3 over 3. I hope that helps you. Remember, a reference angle is always acute, which means it's less than 90, and it's always positive. Okay, so use this, and that'll help you on your review. Good luck.